Hello students, welcome back. Let us resume our discussion in section 2, the law of sines. Remember the law of sines? Sine of capital A over small a, sine of capital B over small b, sine of capital C over small c, they're all equal. Or equivalently, take the reciprocals of all those and write like this, as in the second expression, the equivalent. Here, capital A, capital B, capital C are the angles, and small a, small b, small c are the opposite sides, as you can see in this picture. Okay, we went through a couple of examples here. Typical example when we know two angles, and then the third angle follow immediately. And then using this, we know all the denominators, and then we know one of them, so we can find out two numerators. Easy. Now this is going to be harder, second type. One angle, and then two sides. And if the two sides here are B and C, and capital A's angle in between, then we can have a uniquely determined triangle, yes, but that'll belong to law of cosines. Will law of sines work there? I'm not so sure, frankly. SAS is law of cosines typically. But we can try some law of sines. Let's see, how about this one here? Capital A is 43.1 degrees. Small a is 186.2 and small b is 248.6. It's similar to problem B in a sense that capital A, small a, and small b and small c. Aren't they being a bit too redundant? I don't know. We'll try. We'll find out anyway. So what do we have here? A is 43.1 degrees. It's approximate, but typesetting this is difficult, so I'll just use equality and make adjustment at the very end, alright? B is, okay, that's unknown. C is, okay, that's unknown too, right? A is 186.2. B is 248.2. C is unknown. Okay, alright. And then we have couple of angles to determine, so I have a feeling this one is going to be better. Majority wins. Here only one numerator, here two numerators, so I think this one is going to be better. And let's take a little bit bigger font. Okay, here let's put some numbers in. Capital A is 43.1 degrees. Capital B, I don't know. Capital C, I don't know. Small a, 186.2. Small b, 248.2. And small c unknown. Again, similar structure. Disregard this. Using this equality, I can identify sine of B. From there, capital B. And then, once you have two angles, I can find out the third angle, because internal angles must add up to 180 degrees. And then, if I get everything other than just C, finding that C out will not be that hard. Okay, that's the strategy. So forgetting about this, let's take only this part. So copy and paste. I'm disregarding this part and flip, and then I'm gonna get sine of capital B is this one here, but I'm flipping the denominator to the other side. Oops. So that's a computation I have to do, and if I do that, what do I get? I'm curious. Let's just do it. And then this one is sine of this, and this is Mathematica, so I have to convert it to radian measure to do this computation, and I'm getting 0.91 something, approximately speaking. Okay, very close to 90 degree here. Sine is 1, that's 90 degree. A little bit less, but very close to 90 degrees. I got that. And then, what is my angle B from here? Do I take inverse sine of that? Well, I'm getting a bit tired here. It's a lot of computation to do, a lot of punching to do. So let me go ahead to this answer key and skip some of the computational steps. Alright, this is what we got so far. And if we take inverse sine, we're going to get 65 point something degree. And then another possibility is 180 degree minus that is 114 point something degree. In both cases, we have valid angle C. So in this case, we do not have a unique triangle, but two possible triangles. One given by capital A as 43.1 degrees, and capital B as 65.8 degrees, and capital C as 71.1 degrees. The second triangle has 43.1 degrees, and 114.2 degrees, and 22.7 degrees. So, two different triangles. So for each, we have to find out small c. So B is this, and capital C is that, and B is this, and capital C is that. From law of sines, doing your computation, you get 257.79, 105.25. We have two possible triangles. And from the textbook, we have two pictures here. I just copied and pasted. And A is 186.2, 186.2. This is 43.1. So we have either A, B1C, this acute triangle, or A, B2C, this obtuse triangle. So, angle capital A, opposite side small a, and adjacent side small b are the same, but angle C, angle capital B, and small c, they can be all different. So we have two different triangles. It's been a really, really long time since I wrote this kind of problem in the exam. I'm not saying definitely never, but I'll say rather unlikely. First two types of problems are far more realistic for exam problem. For part D, I have a feeling this may be even invalid. Wait a minute, there's some redundancy here. A 42 degrees came twice. Okay, alright. Let's correct that. A is 42 degrees. And opposite side A is 70 units, small b is 122 units, similar as before, and then we can find out capital B and then capital C and small c. So what am I talking about? It's going to be a similar situation as before, like this. And then we know capital A, that's 42 degrees. And A is 70 units, all right. And B is 122 units. And disregarding this, you can find sine of capital B. So let's find out angle capital B. And using those two angles, find angle capital C. And then finally, let's go to small c. Same technique as before. Let's see what happens here. Work it out. And sine of B has to be 1.16 something. That's not possible. Sine function is always bounded between -1 and +1. And okay, if you go through graphs of sine function in the next week, then you'll see clearly, but at this moment, just use your calculator. Inverse sine of 1.6 something. You're going to get an error message. That means such an angle doesn't exist. So, such an angle B cannot exist, so such a triangle cannot exist. So it turns out this is an easy problem. As a matter of fact, I can say there is some chance you may encounter this kind of problem because the computation is not crazy. Alright, we went through some examples about solving triangles. The typical case, two angles and a side, everybody should be able to do. And a not so typical but turns out unique case, alright, that's okay too. But this kind of problem is not for everybody. And then invalid case, actually, it may be a bit of a surprise, but everybody should be able to do that because in the end, the computation turns out to be the simplest in this case. After a couple of computation, oh, invalid, no more, and then you can walk away. So it's actually an easy problem. Theoretically, it may be hard, but computationally easy. All right. Any other questions? Let's see. We have some application problems here. Do I have enough time for that? No, not really. Not really. So I'll just stop here. And let's meet again in the next video. See you soon.